Hello friends, welcome to Usman Chayin Physics Maths class. In our tutorial today, I shall provide a solution to the problem before us. The question reads, calculate the effective capacitance of the circuit above. So you need to understand that this very particular circuit is not a circuit of resistors and it's not a circuit of inductors. So this circuit combines both the series arrangement and the parallel arrangement. The formula in which we're going to use in calculating the parallel arrangement when resistors are connected in parallel is quite different with when capacitors are connected in parallel. And here we are. Let's first checkmate which of these capacitors are connected in parallel. That should take us to 2 microfarad, 2 microfarad, 2 microfarad. These three are in parallel arrangement. So we first deal with them. This should be C1, this should be C2, this should be C3. So we break them, okay? So for the parallel arrangement, we can say our C total is equal to C1 plus C2 plus C3. When capacitors are in parallel, you should just add them up, okay, to look for the total capacitors, okay. So this is going to give us 2 microfarad plus 2 plus 2 all in bracket microfarad, and this is going to give us 6 microfarad. It means that the total capacitors in series there is 6 microfarad, and automatically this circuit will turn into something like this, okay. So this is 2 microfarad, this is 2 microfarad, and of course this is going to be 6 microfarad. All right, so if that is true, we're going to now look for the total capacitors in the circuit and the effective capacitance in the circuit. All right, so effective capacitance in the circuit, this is capacitors in series, not resistors in series. So we're going to use it in this, we're going to use this very particular formula. C total will now be equal to C1, C2, C3 all over C1, C2 plus C2, C3 plus C1, C2, okay, C3, sorry, C3, C1, C3. All right, so we can use this very particular formula. All right, so if that is true, we cannot rename them. This can be our C1, this can be C2, and this can be our C3. So our C1 is 2 times C2 is 6 times C3 is 2 all over C1 is 2 times C2 is 6 plus C2 is 6 times C3 is 2 plus C1 is 2 times C3 is 2. All right, so this is going to give us this automatically we're going to give us this. We'll now set our C total will now be equal to this times this times this. This is 12, this is 24, so we're having 24 all over. So this times this, we're going to have 12 plus 12 plus 4, okay. So this, if you add them up, you're going to have 24 over 28. So we said 4 go into 24, we're going to have 6 times, then 4 go into 28, we're going to have 7 times. So our answer is 6 over 7 microfarad, and that is it. That is our final answer. Our final answer is 6 over 7 micro